So Unit 3 is talking about describing data. So we're actually going to take samples and figure out or calculate attributes about the data. So today we're talking all about measures of center, which includes mean, median, and mode. So when I'm talking about mode, that is the data point or points that occur the most often. Mode is most. There can be no mode, or one, or several. The next is called the arithmetic mean, or I just call it the mean, which is the average of the data points. There is like a fancy formula that I could write out, but I think all of us here feel confident in finding the average of something. You add them all up, divide by how many there are. So you guys have already done that in this class, so I feel confident. Okay, here's some notation that you might just see and we'll have to use in this class. The first thing is sigma, which is the sum of, yes, the sum of something. When you just see the letter X, that's like a specific value or a specific data point. When I say N, that's my sample size. That's a lowercase n. An uppercase N is my population size. Nope, that's not how you spell population. Population size. X bar, that's how you pronounce it. X bar, because it has a bar. That is my sample mean. And would this value be a statistic or a parameter? If it's the sample mean. Statistic. And the next notation is called mu. That's how you pronounce it. And that is the population mean. So would that be a statistic or a parameter? Parameter. So when you're reading a problem, the context will indicate whether we're talking about population or sample. But the way that they are calculated is the same. So calculations are the same. You're still going to add them up and divide by your sample size or population size, but the notation that you use in front of it is going to be different. So example 1, with your calculator, I want you to calculate the population mean. I don't have the table in front of me. Okay, so then I would say mu equals 79. Why is it mu? Population, yep, so you would only get partial credit if you didn't put mu, and if you put X bar, it would just be wrong.
Wait, you just have to put it in?
Yep, the Greek M.
It looks like an M.
It's like a curly M, or kind of looks like a curly U in my opinion.
Yeah,
Yeah,
it's like
just like that. Okay, so part B, it says, suppose we take a sample, which consists of Ryan, Dave, Joel, and, so that should be Sam, I guess, not same. Compute the sample mean. So what numbers am I going to add together? 77 plus 68 plus 74 plus 84, and then I divide by what? 4. And I get X bar equals 75.75. Good.
Wait, so that's X bar?
That should be X bar. So the next measure of center is the median, which is the middle point when you order it from least to greatest. So make sure you have to order it first. If you have an even number of data points, then you're going to average the middle two. So if you had 20 data points, you would take the average between the 10th and the 11th one. But if you have an odd number of data points, it's just the middle term. So if there's 5 data points, you would take the third one, would be your median. It says find the median of table 2. So the first thing I need to do is order them from least to greatest. So which one is the smallest? 179. Then what? 201. 206. 208. Okay. I kind of ran out of room, and that should be 57. Okay, so how many data points are there?
9.
There's 9 of them. So is that odd or even? Odd. So it means I'm going to take which one is my median? The 5th one. So 217 is my median. Be the 5th observation. And there's no special symbol for median. So you would just say median equals 217. Okay, the next one said find the median of table 1. So ordering them from least to greatest. What's the smallest? 62. 68. 71. 74, 77, 84. Perfect. And how many data points are there on this one? 10. So that would be an even. So which two ones will I take the average of? Between
82.
Yes. So between the 5th and the 6th one. So I need to find the average between those two, or the midpoint between those two, which is 79.5. So if it's an even number, you take the average of the middle two. Odd number is just the middle term. The last type of measure of center is called the mid-range, which is just taking your lowest plus your highest and then dividing it by 2. So it's like the average of your endpoints. So in table 1, what's my lowest observation?
62.
And the highest?
94.
And I'm going to add those, divide by 2. What do you get? 78. In table 2, what's my smallest?
Is there a symbol for this?
No. Just me.
Is 179.
179.
284.
284 divided by 2. 231.5. Perfect. Yes, there is no symbol for this one either. Just for the means. Okay, so the next thing we're going to do is I want you to turn to page 65, and we are going to get some practice with plugging data into our calculator. So not putting data in by hand, like typing every single number in, dividing by 10 or whatever, because there's going to be times where you have a lot of data points. So it's easier to just put it into a list, and then it'll calculate the mean and the median at the same time. So if you have an 84, I'm going to show you what to do. You should hit the stat button, stat, and then edit. Stat, edit,
Okay, so you just hit the stat.
stat, edit. That's all we've done so far. So I've got a lot of stuff in my list. You may not have anything in there. If you do have things in your list, what I'm going to do is I want to clear my list 1. You can individually delete every single one, or if you scroll up to the top where L1 is highlighted and then hit enter, then you'll see like a blinky square. You see that blinky thing? Hit clear and then the down arrow.
Where's the gap?
Down right here.
Oh, wow.
So now my list 1 is empty. If you hit the delete button instead of clear, it will actually delete the entire column and your list 1 goes away, which is bad. Your calculator will just blow up.
The clear button?
No, clear is different than delete.
Oh, there.
Delete is up here, but clear is down here. So if you delete your entire list, the only way to recover it is to clear the memory, which I can help you with if you did delete it. So what we'll do now is you see set 1, which I think it has 20 data points. So I'm going to type all 20 of them into my list. So I'm going to hit 3, enter. And I'm going to type all of them in.
Wait, where are you getting those?
Set 1 on page 65.
Oh, okay, sorry, I missed something. Here we go.
So you go all the way up to L1 and you press delete.
Clear. Don't hit delete. And then the down arrow.
Did you just do it?
Oh, wait.
No, I didn't do
She's on TI and you're in the...
No, no.
And then we go to list 2 and do the other one, right?
Nope. You should have all. Are there 19? Did I skip one?
Oh, wait, that's all on one list.
Yeah.
We have 21.
I have 21.
I have 21.
You should have 20, but I skipped one. Okay.
21.
Which one did I skip?
Wait, no. I think
Probably forgot one of the 7s.
Maybe. Gonna go up to the top. 3, 5, 6, 10, 6, 7, 7, 8,
8,
4, 5.
6.
Oh, wait, no, 6.
Yeah.
4.
4.
Okay, I'm gonna add 4 at the bottom because it doesn't really matter the order. Okay, I'm gonna add a 4th bottom. So basically you should have 20 data points, and then if you were to type in another one, it would say 21. So does everybody have data typed in? Yes? So from here, I'm gonna hit the stat button again. And then I'm gonna hit the right arrow to where calc is highlighted. And then hit enter for one var stats, which just means one variable statistics. List 1 should already be typed in there. Does anybody not have list 1? Like have a different list? No? Okay, good. And then I'm gonna scroll down to calculate and hit enter. So,
It makes
Whoa.
everything
so you're gonna need a lot of these later on. Right now we're only gonna look at 2 numbers, but then eventually we'll use all of them. Right now the only 2 that you need are the mean and the median. So the mean is 6.5. And even if, like in this example, we're talking about a sample, but even if we were talking about a population, this number would still be correct. But what I would expect you to write down is mu equals 6.5. So because those numbers are the same, your calculator just defaults to sample, but so it's always going to use X bar, but you can decide whether it's X bar or mu. In this example, if you read at the top, it says 3 different samples. So this is a sample. So I will put X bar equals 6.5. Then if you scroll down on your menu, so hit the down arrow, you'll see your median,
6.5.
which is also 6.5. So my mean is 6.5 and my median is 6.5. What we're gonna do now is we're actually gonna make a dot plot with our data because we're gonna see, okay, the mean and the median are the same. We're gonna decide like how that relates to the shape of my data. So making a dot plot out to the side. Do what?
Never mind.
You're all probably faster than me, so you can go ahead and start it. Your dot plot should look something like this. If I were to give this dot plot a shape, what would I say? Bell. Bell-shaped or symmetrical?
Oh, jeez. Wow, it's perfect.
It is perfect. Bell-shaped. And also you can X out that chart below. We're not ever going to do anything with that. So if you want to mark that out where it says length and then X minus X bar, we're not going to do anything with that. So the next thing it says is suppose that the 10 inches is 15. So I'm going to go back into my list. This is just showing you how you can edit one data point. If I go back to stat, edit, if you scroll down to the 10, where it's highlighted, if you just type in 15 and hit enter, it will actually override that.
Boom. You
So-
got the stat out.
Mhm.
What's that?
So then I'm going to calculate the new mean and median from that. So stat, calc, enter. And what is my new mean and median?
Median's the same.
Median is the same. Mean went up 6.75. So what I want you to do with your table is I want you to finish this. So go change the 10 to 20. Then I want you to type in a completely new set, 2 and 3. Find the mean and the median, and then draw the dot plot and describe the shape. So I'm going to give you guys 10 minutes. That's about until lunch. And then we'll come back and talk about it. So with your table. So the median was 6.5, right? But the mean went up to what? 7. So whenever I changed the 10 to 15, it only went to, the mean went to like 6.75. And then I made that outlier even more of an outlier. Like I shifted it even further, and my mean went even further. So, but my median stayed the same. So we call that being resistant to outliers. So hold your paper there and flip back to the notes where on page 61, where you see the word resistant. Resistant is a measure that is not affected by extreme values or by outliers. So when we changed the upper data point from 10 to 15 to 20, we were making it more and more and more extreme. So would I say that the mean is resistant, meaning like it's not affected by outliers? No. The mean is not resistant because it is affected by outliers. Would I say the median is resistant? Yes. Because even though I changed that one data point, I kept moving it out, my median is still safe in the middle and nothing is changing that. It's in the middle of the data point.
Is that always the case?
Uh-huh. If I'm not adding or subtracting any data points, but I'm just moving one to a different location, then it's not going to affect the median.
Million, it'd still be the same median.
Exactly.
I knew this before I took the SAT.
So the next part was typing in set 2 and set 3. So when you typed in set 2, you got what for the mean and what for the median? 6.8, 5.5. Okay, so the mean was greater than the median. And when you drew your dot plot, what kind of shape did it have?
Right.
It was right skewed, so it looked something like that. It was a right skew. So your mean is always going to pull towards the tail. So basically your mean will be greater than your median on a right skew. When you did set 3, what did you get for the mean and the median? So in this case, the mean was less than the median. And what kind of shape did that one have? A left skew. So the mean pulls towards the tail. It's going to be less in a left skew, and it's going to be greater in a right skew. So if you go to back to page 61, when you have a distribution that is skewed left, I'm going to say my mean is less than my median. When it was completely symmetric, what did you notice about the mean and the median? They were the same. So in a symmetric distribution, the mean equals the median. And when it is skewed right, the mean is greater than the median. So moral of the story is that the mean always pulls towards the tail. So if the tail is to the right, it's going to be towards the right. And then if it's towards the left, towards the left. So we're going to do one more slide and then it'll be lunchtime. We won't do anything else until after. So when I talk about things that are bimodal and multimodal, you can kind of see just from the pictures that you've been given, if something is bimodal, that means that it has two modes or two instances where it has the highest frequency. So if you look at the data from a graph, yes, like one mode is higher than the other, but when you clearly see two peaks of data points, you would consider both of them the modes. So yes, you have one ultimate mode, but you would want to mention both of them because they both occur frequently, looking at the pictures. When you see a graph that is multimodal, that just means more than two modes. So yes, like looking at the bottom left graph, the 210, or I guess 205 bar is the highest. So that is like the ultimate mode. But also at 175 and 140, those are both modes too. So you would want to mention every single peak. Two of the data, like A and B are for sample, C and D are for population. So what notations am I going to put next to A and B?
The X bar.
X bar. X bar. What's C and D? Mu. So doing these, you can either, you have two options. You can just do it by hand, like typing them all in, adding them up, dividing, or you can put them into a list. I will let you choose whichever one that you want to do, but I'm going to give you 2 minutes to have the answer for A through E.
How do you get back to the calculation page?
Hit second quit, which is next to it. There you go. Okay, what did we get for A? 11? What do we get for B?
82.
What do we get for C?
9.
What do we get for D?
15.
And what did we get for E? 5 million. Would this be a mu or would it be an X bar? Mu, because it's all 65. Yeah, it's not saying a sample.
We have to put one of those
Uh-huh.
on.
Okay, example 5. Here we've got 5 or 6 data points. I could either put them in a list or I could do them by hand. I feel confident in you guys finding the mean, but if I were to do the median by hand, explain to me how I would do that. Least to greatest. How many data points are there? 6. So I would do what?
Add 2, divide by 2.
Take the 2 middle ones, divide by 2. Okay, I'm going to give you 1 minute to do this. So what did you get for the average? 423. So since this is talking about dollars and cents, we'll just go out 2 decimal places. And then what's the median? 40.76. Y'all both got it wrong? Oh gosh. Yeah, the thing about this is you have to be really careful when you're typing them in because it's easy to make a mistake. Okay, example 6 is finding the population mean for travel time. So it'll be mu. And then for the sample mean, it says a sample size of 4. Let's just take the first 4. Oh, it is convenience, but we're going to do that just because.
Wait,
Wow.
I know.
What if we come
We don't
to?
do the whole population.
We'll do the population one first, and then we'll take the first 4 people. I just feel like being convenient today.
Wow.
I don't know how I feel about that.
That's a good thing.
That's kind of
Okay, we've got.
Tiffany. We got Tiffany.
Okay, Tiffany.
oh my god.
We got Tim.
Oh,
I knew Tim was
alright.
going. We got Erica.
Who says Erica?
And we got Amanda.
Okay,
8, 3, 7, and 1.
on what I guessed he would get random numbers.
I'm so proud of you.
That's crazy.
Alright.
I
Now
did
we can
kids
continue.
excellent, so.
Thank you for keeping me above reproach like that. I almost fell into a bad way, but
Slippery slope. What?
Wait,
15.
That's
anybody get it yet?
26.4.
And then what's our sample mean?
25 minus 25.
17.75.
That's the median.
Oh.
The median is 25.25.
So basically, Tiffany, Erica, Amanda, and Tim had their combined averages were lower than the average overall.
Okay.
It's kind of sad.
But we kept our integrity.
We did. Okay, we're going to do one more example. So you're just going to write example 7. I know, you thought it was done, but it's not. Example 7. And this is called a weighted average. Which you may already know how to do, but I'm going to show you 2 different ways or 2 different examples where you'll see something like a weighted average. So let's say that my honors statistics class, so I'm going to say honors statistics class had an average test grade of, I think your average was an 85, which is really good. Yep. And my AP stats class had an average of 80. But my honor stats class only has 14 students, and my AP stats has 22. So if I were to just average both of them together with no weights, then the average would be 82.5, because it would be like 80 and 85. But since I've got more students in AP than I do honors, which number is it going to be pulled towards more? The 80 or the 85? The 80, because there's more students in there. So to figure out the weighted average, I'm going to take the total number of points over the total number of students. Which, to find the total number of points, I'm going to take 85 times 14 plus 80 times 22. And that's going to be divided by how many students I have in both classes, which is how many? 36. Good. Caroline, do you want to do it for me?
Caroline doesn't mess up that, but
She doesn't know how to type buttons in the calculator.
I can't read very well. I don't know.
You should get 81.94, which is a mu, because why? Yeah, it's all of my students in both classes. So if you put 82.5, you would be wrong. This would be your considered your weighted average.